To graph the linear inequality. We're given here an equation that is in slope-intercept form. When it's in that form, it is quickest to just simply graph it using the slope and the y-intercept. You can see here that the y-intercept, which is always in the back of the slope, it is -3. In terms of its location on the rectangular coordinate system, it's going to be 0, -3. We see here we have a negative slope. So when you have a negative slope and it's a fraction, you can write it either way. You can write it with the negative being on top, or you can write it with the negative being on the bottom. It does not matter. Each way is fine. I'm going to go ahead and write it with the negative being on top. We know that if the top or the bottom is negative in a fraction, it makes the whole fraction a negative. But in terms of writing it, you write it as one or the other. So beginning with plotting the y-intercept, that's 0 and down 3. From that point, we are going to fall down 2 and run 3 to the positive side. That takes me to my next point on the line. And what type of line are we going to sketch? Is it a solid or is it a dashed? Well, if we look at our given equation, we see that we have that line underneath it. It's greater than or equal to, which means that we are going to sketch a solid line. I also want to point out that for this particular slope of -2/3, as I stated before, you could have also let the top be positive and have a +2, which means you would rise up 2, and then your bottom in the case would be negative. You would run 3 to the negative side. And I just wanted to show you that in either case, you would still be on the line. So notice that my line goes through all 3 points. Now you only need 2 points to plot a line. I only did that to make a point that when you have a negative slope, it does not matter whether you make the top negative or whether you make the bottom negative, you're still going to be on the line. And now that we have a line drawn, now we have to determine which side or region we're going to shade. We can use our test point 0, 0, because notice our line does not go through that point. So we're good to go in using that as a test point. So in using the test point 0, 0, let's go ahead and plug in a 0 for x and a 0 for y. You notice that the test point here is the side that is the upper boundary, or to the right of the line. The lower boundary is the other part. So we want to test the test region. If we get a true for the test region, we're going to shade that upper bound. If we get a false for the test region, we're going to shade the lower bound. So plugging in a 0 for x and a 0 for y, we're going to wind up with a -3 on the right side. Let's read the statement. 0 is greater than or equal to -3. Well, 0 is not the same as -3, but 0 is bigger than or greater than -3, because remember, the more you go into the negatives, the smaller the numbers become. So that's a true statement, which means that we are going to shade the upper bound or the upper region. Now there's another method which is called the boundary method. With that method, anytime you have the symbol facing with greater than, it means you're going to shade the upper region. And that's when it's in slope-intercept form, you read it that way. And notice here, yes, we did shade the upper region. If the symbol was turned the other way as a less than, then that would indicate you would need to shade the bottom region. That's the boundary region. Now, the region I've been doing most of these examples with was using the test point region, and specifically using the test point 0, 0 in all cases except cases where it goes through 0, 0. That method will never fail you. The test point method, you can always check that to determine which side that you would shade. And there you have it.